Hello, it's time for trigonometry. So these are notes that you are setting up, and I'm wondering, I'm going to try this. I don't think it's going to work. I'm having some issue with the format. Okay, anyway, that's 20 seconds I just wasted. So first we're going to take some notes, so please follow along, and you can set up Cornell notes if you're used to that. Otherwise, no stress. And so there are some vocab words that I want to define first. So I'm hoping that you'll do this vocab before you watch, or before you do the Desmos. But anything is possible. That might not be true, and I'm worried about it. Okay, so degrees. Degrees. So that is a unit of measurement. Measurement. So you're measuring something, and it's of angles, not angels, angles. And so we'll do, like, that's a symbol you'll see sometime. You might have seen that in geometry. It's also known as 1/360th of the circumference, so that's around the circle. Circumference. There's a good book for kids about that. Of a circle. Okay, cool. Yeah? I'm going to do this vocab. All right. So, maybe you already knew that. I'm not really sure what you know already because I'm not there with you and it makes me sad. The other thing they're going to use is something called anti-clockwise. Oops, I'm going to erase that. Anti-clockwise. And that is the same as counterclockwise. I'm not sure why the switch, but you know, whatever. So that's opposite of clockwise. Opposite of clockwise. So when we go to do our drawings, it's that way. It's also, what did I just say? Counterclockwise is another way to say it. I think anti-clockwise is more universal. Like in Europe, they would say that. Okay, and then the last one, well, it's not quite the last one, is quadrant. And a lot of you have been using this word throughout your math life, which is great. But the actual definition of this is from a circle, which is kind of cool. Each of 4, quad, right? Like your quad in your leg. There's 4 muscles that make up the quadricep, in case you didn't know. 4 quarters. I digress. Quarters of a circle. They're also numbered anti-clockwise, which is, again, important. So you have 1, 2, 3, 4. Okay, so questions you might have are, well, I don't know, but let's go ahead and do this for a second. Like, how do you calculate, or how do you find, calculate degrees? Oops. Something like that. Other questions you might have for later. The other thing I'm going to add right down here below a little star. So there's something called sine and cosine, and I'm actually going to give you a little reading about the history of that because it sort of comes from a mistake, which is cool. And so sine maps to y and cosine maps to x. So cos is the x, sine, we say sin, is the y. And so we're talking about x, y coordinates. see that on the next page here. All right, I'm going to highlight this whole section. All right, let's look at the next page. We're going to look at the unit circle, which is a little bit much, but it'll be okay. Okay, I'm going to zoom just, well, maybe not. All right, stay calm, please. Everything is fine. What can I do? I can do anything. I can draw this. I'm going to draw my axes because I want you to know that this is just an XY axes, right? So we say X comma Y. And so you have all these lines. We're going to focus on the first quadrant. So like this is first, second, third, fourth. If you know the first, you can build the second, and then it's just a reflection across the x-axis. So everything we've done up until now has sort of led to this moment, which is amazing. Okay, so we're doing degrees only right now. There are radians, but we're only going to do degrees for this first one. So if you see something online that has radians or has pi in it, chill out. That's my official advice. Okay, so let's think really quickly about, I'm going to do the big ones that we know. So from 0 degrees, 0 degrees, up to 90 degrees, 90 degrees. Okay, so then if I add 90 more, I get 180 degrees. So this, I'm hoping that maybe you remember from geometry. This one, I sometimes forget. I'm not too embarrassed to admit it. But it's like 9, 18, 27. It's multiples of 9. Well, 90. So this is 270. Sometimes I want to call this 300. It's not. And then this other one has 360. Oh, I did this wrong. Shoot. You're fine. Because you just drew a circle, right? Do you see, though, that I need to put the degrees on this other dotted line? Dang it. Sorry, y'all. It's cool. You have time. We're chilling. Okay, my bad. So this is 0 degrees. This is also 360. This is 90. This is 180. This is 270. Okay. And that is just because I know that a right angle is 90 degrees, right? So I know, in theory, nothing about the unit circle except for that. Okay, so we're going to operate on half scale here. So halfway, I'm going to use blue. Halfway, right? Skirt. Well, you get the idea. In real life, this would be so much better. So then half of 90 is 45 degrees. So I'm going to write 45 here. So from this 45 degrees, I'm thinking about mirroring that over in quadrant 2. Right? So this would also be 45 degrees up from that axis. So I either can subtract 45 from 180 or I can add 45 onto 90. For me, it's easier to add. So this is actually 135 degrees. Yes. So the same is true if you flip it, right? So this is why we did transformations. I'm going to redo that. You didn't see that. Squelches. It's like a little butterfly thing, pasta looking thing. Oh my God, I'm so hungry. Okay. So same thing, 180 plus 45. So 20 is 205. No. What am I doing? 45. Why am I pretending like I could do this right now in my head? 5. What is that? 12. 225. Yeah? Okay. I have a little cheat sheet here, but I'm not trying to cheat in front of y'all. Okay, and then for this one, same thing, I can subtract 45. Oops. I can subtract 45 from 360, or I can add it to 270. So if I add 270, legit cannot do this. 315, duh. Some of these I remember, and then some of them I forget because it's been a while. Okay, so from here, right, like you can build the rest, which is so cool, and it's like this magical gift of magicalness. I'm going to use green because I'm going to get a little bit weird with it. So this is a third. So 1, 2, oh, you can't see that. 1, 2, 3, right? Cutting a piece of pizza, you need to have equal slices. So this is 30, 45, 60. So from, again, this first quadrant, if I can get this first quadrant, I can get everything else. And then we'll see some nice properties happening with the multiples. So this is 120, 135. This is 150. 180. Oh, crap, I wrote it in the wrong place. Dang it. That's okay. Everything is fine. What am I doing? 150, right? It's gorgeous. So same thing. I'm going to add 30 degrees to 180, which is 210. So that's a nice thing that's happening. Add 30 degrees. So that's 240. It's a nice multiple. That's a 4, y'all. And then 270. Here's my 300. So this is the one I always want. And then 330 shows up. Oh boy. And then my 360 is already there. So one important takeaway I'm going to write up here is like multiples. Multiples. The other thing I'm going to say out loud at minute 6:42 is that legit in all your math textbooks in the future of your life will have like an inside cover that has this printed on it. So like chill out a little bit. Okay. The unit circle, though, is not complete. Let's switch to red. Let's get a little aggressive here. So you're going to see that we use a radian of 1. So this is 1, 0. And this is 0, 1. You need parentheses. You need your Huggy Boys. You need to write it as X, Y. You have to. You have to. And so this might give you some flashbacks to our imaginary numbers. Oh, remember the good old days when we still could see each other? I miss you guys. All right. So that's all I'm going to do for right now because the rest are decimals, they're radians. So I'm going to leave these as question marks. And we're going to come back on the Thursday video, hopefully. I hope. I guess I'm in charge. We're going to come back on Thursday and fill those in. So I'm going to say over here, the questions are radians. And we don't really know those yet. So we're just focusing on degrees. If your circle is not perfect, that's fine. Make it look kind of symmetrical. If you have the luxury of tracing something that's cylindrical on your paper, you could like cut it out and you can like fold it, sort of like origami, and that would help. Okay, so you're going to do some practice with just degrees. So that's all. Yeah, stay calm. All right, I can't wait for the rest of this unit. It's so magical. Okay, bye. Hey, wait, just one more thing before I forget. So, so this is your oh crap. This is your cosine and this is your sine. So when you have cosine of 30 degrees, you're going to have a number here. So you'll see that in the Desmos. And so this is like on the last page, this is cosine and this is sine, S-I-N, like sin, but we don't say that, we say sine. And so it's common. I just want to do like a star down here. So if you're thinking of like cosine of, I don't know, I guess 90 degrees. So if you input 90 degrees, your value is actually 0. So I'm allowed to input degrees. And we'll see that a little bit in Desmos, not really, but I just wanted to add that little last thing because I know the Desmos asks you about it. Okay, sorry, bye.